Welcome back. We're writing Little Man Computer in C++, and we've just dealt with the process of splitting up an individual instruction string into its component parts, the label, operation code, and the address, ignoring any comments that might be on the line. And what we want to do now is we want to be able to iterate through a series of these instructions or a series of text lines and parse all of those into some vector of instruction objects. So let us start by examining the tests and writing something. So we finished with this. What we want to do next is we want to do something which will given some sort of input stream, iterate through the lines and produce a vector of instructions. So working backwards from our assertion, we want to say assert r equal some expected instructions and some instructions, so we can create those a little bit at a time. So we'll have a vector of instruction like so, which is our expected instructions, and that's going to be something along the lines of, we'll start simple and we'll just have a single halt instruction like so, and we want the instructions, which we've spelled wrong down here, to be equal to our assembler. I guess parse instructions is not an unreasonable name, and then something like in an input stream. And we need to fake this input stream because we don't really want to be opening files and creating files in our tests here. At least not at this stage. So we will create some sort of, and I was having a little bit of a Google how to do this. I think we need something along the lines of an iString stream, which will look something along these lines, I guess. We'll need to include string stream in our we'll need to include string stream in the includes like so, just so that we can use it, and then we can create a string, which is our input string, I guess. Input's probably fine in this case, and that's going to be something along the lines of a label that we're ignoring and a halt instruction and an address like so, and then we can create a string stream and is that with, I don't know what the difference here is between doing it that way and doing it with the braces, but we'll leave it like this for now. I think technically the difference is this is calling the constructor, whereas with the braces like so we're directly assigning to the fields inside the object structure. So this will have some missing things. Let us see what they are. So we are missing an assembler, and we're also missing a semicolon on the preceding line. No, yes, no, yes, yes. So we're missing a semicolon here. We are missing an assembler. Let us see if that gets a little bit nearer. Excellent. We're missing a parse instructions method, which is what I was expecting to see. So we can go to our assembler header file, and we can create a new method that returns a vector of instructions called parse instructions, and that takes I'm not sure the const etc-ness, so we'll be as conservative as possible here until we know more, and do this. This will hopefully be fine. We do not have an include of streams, so that's going to be, I guess, IO stream maybe? We'll have a hunt for that if this is insufficient. That's, oh no. We've got to the, we've managed to encounter the same problem that we had before. For some reason, including stream things makes the all of not work. I wonder if we'll have a quick Google for that. See if anybody knows what's going on here. That's not quite what we're after. Maybe we'll have a look at the particular error that we have in here, if I can find it. So something like that. Let's see if anybody else has found this issue. Did I? It's certainly possible that that's an issue, and we're somehow circumventing that. So if we go to, I thought I'd included that, but apparently not. So if we go to assembler.cpp, we aren't including algorithm. No, that's not the issue. I thought we'd tried that before for some reason. This is a bit of an annoyance if it's going to stop us being able to do any work beyond this. It's interesting that that works without I have a suspicion this is some other error that's being subtly masked here, but I'm not entirely sure what it is. That's not what I meant. So, is digit, I think, is part of string. Let's do that here. Is check we're not missing that instead. Apparently in CC type, that's that's hiding. I wonder if we were to do that, whether that fixes the issue. No. I did indeed mean that. Let's at least do that. I don't think that's going to fix the actual issue we're looking at here. No matching function. Now, I have a suspicion that it's not that all of is not matching, but that the particular signature doesn't match. Couldn't infer argument to predicate is digit. So maybe if we hunt it down from that perspective. I wonder why. Interesting. So K is in a non-deducible context in that example. I wonder if that's going to be the issue here. Is digit. Let's see. So let us have a look at the all of reference and see what the last parameter is. It's a unary predicate, and you can just do it directly here, where that's the scope, that's the parameter, and that's the result. So what does is digit return? What's the signature of is digit? Takes an int char. So if, for example, we were to do this instead, a little bit messy, but perhaps worth a punt. Ooh, that's fine. I think that's a completely different problem here. Good. Let us quickly do a little bit of tidying here. So I think we can now move that here, and that will still compile, other than the issue here, which I think was just a case of using the wrong assert. No member, no matching call for assert are equal. Yes. Collections of int. Oh, we're gonna have to be doing awkward things here, aren't we? But that's fine. We can work with that. So let us just say this for now, as we're only expecting a single item, although there may be some initial issues with segfaulting if we're not careful. but we'll deal with that as it arises. Yep, okay, now we have no implementation of this instruction here. So we can create that, like so. Let us just prefix things. Oops. Assembler. And then we need return of type instructions, and we can return that. And we can make that maybe unused. At least we could if we spelled all of the word. And just see what that gives us. Probably a segfault for having no element 0 in our returned values, which is fine. It does indeed. So if we make that pass in the simplest possible way, we would just do the following. Create a random halt instruction, like so. And that should, I believe, pass the test. Hopefully. And indeed it does. We haven't given the test a name. So we should do that now. We want input stream with a single halt instruction creates the correct instruction vector. That should be fine. And if this passes, I think we can just do a little bit of refactoring to give ourselves a slightly nicer... Oh, hello. That's very strange. What's happened here? All sorts of interesting things, I assume, in the way that we've created this instructions vector. I imagine. So what's that all about? Is that because we're passing that back? Would it be preferable to instead do instructions push back? I don't know if we can do this. I don't know if there's a huge difference between those, but we'll at least give it a go. I'm sure we're doing this something similar elsewhere, but possibly not with a vector of instructions. It's interesting that it's also a runtime issue as opposed to a compile time issue. That seems to be okay, so we'll live with that slight reformulation for now. Let us see if we can quickly do something here where we want to essentially duplicate this and handle instructions instead of ints. Feels like we can probably make use of proper, I say proper, but equality compare behavior implementation equals operator implementation inside instruction. I don't really want to do that because it's not part of the public API as such. So here we want to say this instead, except that's going to be expected I and actual I. Like so, and we can get rid of that, and I think that will then let us then say, just assert equality directly. And hopefully that'll simplify future tests along these lines, where we're looking at generated vectors. Hello, I've broken something. So it now fails instead of. I suspect I've just. I suspect that's what's happened is I've got my check the wrong way around. Yep. So these should be ors instead of ands. Which is a relatively straightforward thing to fix. Might need some layout tidying at some point. Some of those lines are a little wide. Partly, I guess, because of the zoomed in screen, but may still be worth improving that. Good. So we've now got a framework for writing these sorts of tests where we can have an input stream string with parse instructions that returns a vector, and we can compare an expected answer. Excellent. So let's commit that. That's all fine. So that's going to be parse stream of instructions with single halt instruction. Excellent, and now we're in a position to carry on a bit more swiftly next time.